Okay, so hello everyone. So I'm going to show you how you can use ray diagram to describe the image formed by curved mirrors. So for ray diagram, there are four principal rays that you can use so that you can describe the image form. However, to make it easier, I'm going to show you two important principal rays that you can use so that whatever is the location of the object in front of the curved mirrors, you can still describe the image form. So first thing, we're going to start first with concave mirror, or also known as converging mirror. So we have the following given here. We have the focal length, which is 3 centimeters. We have the radius of curvature, which is 6 centimeters. For the radius of curvatures, it's simply doubling the value of the focal length. And we have the distance of the object, and we also have the height of the object. So we're going to describe the image form using the acronym LOS: the location of the image, the orientation of the image, the size of the image, of course, what type of image was formed. So for ray diagram, the first thing that you need to do is to get your ruler. Using your ruler, you draw horizontal line, which is our principal axis. So you need your ruler and your pencil. Okay, and a piece of paper for this. And then after that, the next thing is to mark your vertex or point V, the center of the curved mirror. So for this time, I'm going to choose this part here. Okay, no, ito na lang. This one here as the center of my concave mirror. And the next is to measure my focal length from the vertex so that I can mark my focal point, or F. So I have here 3 centimeters. So from the vertex, I'm going to, so this 1 centimeters to 3. So I'm going to mark this as my focal point. And again, I was able to measure that using the value of the focal length. And the next is to mark the center of curvature. Now you can mark the center of curvature if you know the value of the radius of curvature, or by simply doubling the value of the focal length. So from the vertex, okay, or from the focal point, you can either use of that, from the focal point, okay, that is another 3 centimeters, so that I have 6 centimeters. So this is 3 centimeters, and from here to here, that's another 3 centimeters. So that is equal to 6 centimeters, which is the radius of curvature, and that will help me mark my center of curvature. So may I just erase this part here? I just remove it. So I'm going to mark my center of curvature. And once you have these 3 important points, the vertex, the focal point, and the center of curvature, you can now draw your concave mirror. So let's have a simple drawing of the concave mirror here. Okay. So you may use the value of the radius of curvature so that you can perfectly draw your concave mirror. Okay, so that's my concave mirror. And the next thing that I'm going to do is to measure the distance of the object, which is 4 centimeters. Okay, from the concave mirror, it's 4 centimeters. So 4 centimeters, that would be, okay, so that would be here. Okay, that's the distance of my object. So let me just label this. So I have here the vertex, which is marked by V. I have here the focal point. I have here the distance of the object, and I have here the center of curvature. And since given yung height ng object, then I'm going to measure the 3 centimeters. So I'm going to use arrowhead or arrow as the representation of my object. So here I'm going to measure 3 centimeters. There you go. Okay, so this is now my paired array diagram. So first thing is the two principal rays that I'm talking about. So we're going to use PF ray. So may I use a different color here so that you can, I'm going to use blue for the incident ray, and incident ray is always paired with reflected ray, which I'm going to use red for this. So I'm going to use, okay, so I referring to incident ray and R referring to reflected ray, and they are always in pair. So let's have the PF ray and then pair it with our F ray. Okay, and then another important principal ray would be the VV ray. Okay, okay, so these are the two important principal rays that you can use. Again, kung kahit saan nakalagay yung object in front of the mirror, you can still describe the image form. So how will you draw the PF ray and the VV ray? P stands for parallel, a ray that is parallel from the principal axis. F referring to a ray that will pass through the focal point. And when we say VV ray, or V referring to the center, so an incident ray that is moving towards the center of the curved mirror and reflected, okay, away from the center. So we follow the law of reflection here. Okay, for VV ray, we follow the law of reflection. Okay, so let's start. So for the PF ray, so you're going to align your ruler from the topmost part of your object. Okay, so let me just label this as my object. So you're going to align your ruler from its topmost, and you're going to draw a horizontal line, a parallel line. Okay, so this would be our incident ray. I'm going to use blue for the incident ray. Okay, there you go. That is your P ray. That's your incident ray. Okay, and then of course the mirror will reflect it, and from the mirror, the reflected ray must pass through the focal point, the positive focal point. Okay, so you have to angle your ruler, and you have to make sure that your reflected ray came from the mirror and it will pass through the focal point. The focal point which is in front of the concave mirror. So that is your PF ray. So your PF ray, okay, looks like that. Next would be our VV ray. So again, we align our ruler, okay, placing it on the topmost part of our object and angling our ruler here in the center of the curved mirror. Okay, so I'm going to use blue. So as you can see, the angle here, okay, so again from the horizontal line to the incident ray is 36. Okay, you may use a protractor if you have for this. So let's have our incident ray. So from the topmost part of our object moving towards the center of the curved mirror, which is the vertex. And that's why it's called VV, because again, it will be reflected and coming from the center. So let's measure again this 36 here. Reflected ray coming from the center of this mirror. Okay, notice that the two reflected rays, okay, which are the red lines here in front of the concave, converge or meet at one point, or they intersect at one point here. And that point where they intersect or converge, that is your basis on how you will draw your image. So since nasa baba siya ng, okay, so we have here the positive and the negative. So kapag below means inverted dapat yung drawing ng ating image. So from the principal axis, okay, going to the merging point, we have to draw an inverted image of our object. So this is now our image. Okay. So again, we just used two principal rays, the PF ray and the VV ray for this. So notice again that the two reflected rays converge in front of the concave mirror. So if this happened, therefore, the image would be inverted because it was formed at the negative side. So that means it will be drawn inverted. So here, let's use the acronym LOSS to describe the image form. Let's have L stands for the location of the image. Where is the image location? So again, take note of the important places or location in front of the concave mirror, especially if we are talking about real image that are formed in front of a curved mirror. So remember, we can use the following. We can say it is located between F and V, or we can say at the focal point, or between C and F, at the center, or beyond the center of curvature, or beyond C. So these are some of the terms that we can use to describe the location of a real image. So for the location, we notice that the image is located beyond the center of curvature. So we'd say beyond C, or beyond the center of curvature. For the orientation, obviously, if the orientation of the image is different with the orientation of the object, therefore we have an inverted image. For the size, it's very obvious, so we could say it is enlarged. Okay, and for the type of image, since the image was formed in front of the concave mirror, therefore it is a real image. So again, notice how we drew the two principal rays, the PF ray and VV ray, for concave or converging mirror. Kasi iba din when it comes to convex mirror. For the next video, I'm going to show you the important thing that you need to do if you notice na yung reflected rays hindi sila nag-converge or nag-intersect in front of the curved mirror.